Well, I told you this was a doozy. Here's part two. So, moving on, we're going to talk about pest control methods. Um, Pests. What is a pest in the first place, right? A pest is any organism that's damaging valuable crops. Really, it's anything that you don't want. So, a weed is a pest too, right? It's competing with the crop, so it damages it kind of in an indirect way. And so we use pesticides, right? They're basically poisons that target certain organisms. So an insecticide targets insects, herbicides targets plants, fungicides targets fungus. Um, so, you know, in pesticides is really an umbrella term. So pesticides have a long history. In the beginning, they used a lot of metal and botanicals, like nicotine was used as a pesticide. Um, but this is the reason why in the South, like when they grow rice in the South, there's a lot of lead in their soil. And so rice tends to have a higher level of lead in southern rice, like the southern states. So good alternatives are from Asia, and then second best I'd say is from California. But now we're into second generation pesticides, and these include synthetic compounds such as DDT, which we'll talk about a little bit. Um, there are major groups of insecticides. There are these chlorinated hydrocarbons. So basically, it's um, with chlorine in it. This is the what DDT is part of, and these are very slow to degrade. So they're very persistent, which is why we call them persistent organic pollutants. They are banned or largely restricted in the US and really around the world, and we'll talk about that a little bit. Um, and then there's also organophosphates, which actually affects the nervous system of certain insects. Um, and so they don't persist as long, but they can bioaccumulate, which we will talk about in a little bit. Obviously, pesticides have benefits. There is disease control. So, looking at mosquito borne disease like Zika, Triple E, right? All of these newer ones, I'd say they're like emergent diseases, but also the old ones like yellow fever, right? Um, so, those are not good. So, we want to kill the mosquitoes. Um, and of course, malaria, and which is why we really started using DDT because people die from malaria. It is not a fun disease. Um, it protects our crops, so pests can destroy our crops, and so this saves us from from losing money or as a farmer. And I say us. But pesticides also can become resistant. I'm sorry, pests can become resistant to the pesticide. And so pest populations evolve. You have the individuals who are really genetically immune or not as right, not as prone to really being affected by the pesticide because there's genetic diversity, and those individuals will actually survive and pass on their genes, right? It's just natural selection, or really it's artificial selection because we're the ones that are driving it. But anyway, pesticides stop being effective. And so either we have to increase the chemical toxicity or apply more so that the resistant pests will die. And we call this the pesticide treadmill because it has to, or because it keeps happening over and over and over again. So um, cost of applying the pesticide increases because you need those larger doses and you need to apply more in order to put them on. Um, and so the effectiveness just keeps decreasing. And so if you look at the graph on the right, you can see that the number of resistant insect and mite species has increased like crazy. Whereas in the table below, you can see that even though we have, increased our pesticide use, we're still not really losing right? Our rate of loss is actually staying the same. So we're not doing any better by applying more. So in killing those old pests, we create space for new pests to come about because we're reducing their competition. And so we are like so good about one pest and we're like, yeah, we got this. And then this new pest comes along and says, aha, there's room for me now, right? Anyway, and so there is this red scale on trees, right? On, I think they're lemon trees here. And you know, we never had this before, but you have these trees that have been treated, and you have this emergence of this red scale on these lemons. So we got rid of one pest, but we brought in another one. So DDT is a persistent organic pollutant, and any persistent pollutant is going to bioaccumulate because you can't break it down as an individual, right, as an organism. That's why they're persistent. And so they build up the more and more you're exposed to it. And so that would be biomagnification, where it's bioaccumulation, where over time you are building up those contaminant levels. It's accumulating in your own tissues. And then we also see biomagnification, where the higher up on the food chain you are, the more the higher the toxin levels are, because you have to eat what's below you. And so there's just this buildup. You eat those little fish, but the fish will break down, but their toxins will stay in your body and stay there. So biomagnification happens because of bioaccumulation. And this happened with the ospreys. Right? These shells were getting really soft and cracking when they went to sit on them to nest. And right, we had this massive decline in the osprey population because the ospreys were eating birds that had DDT in it, and DDT, right? Those fish were eating smaller fish, and those fish were eating zooplankton, and those fish were eating phytoplankton, right? So it starts at the bottom of the food chain. Each individual accumulates it in its body, and because the top of the food chain is eating all of what's below it, it has a lot of the toxin, and you get these detrimental effects like this. And so when you spray something, it doesn't stay where it's applied. Just because I want to kill a mosquito doesn't mean it's going to stay on the mosquito, right? It's going to move into the water and the soil and the air. And so there are all kinds of ripple effects that happen when you apply these kinds of things. Not to mention, pesticides have pretty big risks to human health. So you could have long-term effects, right? Cancer, breast cancer, sterility, or short-term effects where you just have headaches, nausea, vomiting, and then, you know, in like severe cases, maybe even something happening to your nervous system. And so this is why we banned certain pesticides like DDT during the Stockholm Convention. But you can see that there are only a handful of countries that signed this. Amazingly, we did. So we banned it and restricted it. But some companies actually still make it and export it to other countries who then use it, and then those foods are then brought back into our country. So, you know, DDT is still around. Of course, there are alternatives to pesticides, which we'll talk about more when we talk about integrated pest management. But one of these is actually the use of GMOs, right? It can actually decrease the use of pesticides like this BT corn. So, right, we take the gene from the BT, I'll try and say it. I'm going to say it wrong. Bacillus thuringiensis. I definitely said that wrong. Anyway, right? It creates this, it has a protein that is toxic to these larvae called the European corn borer. And of course, we don't want the corn borer to bore our corn, so we insert the gene into the corn. They eat the corn and then they die. And so, awesome, we don't have to spray pesticides. right? But the problem with GMOs is that it can affect non-target organisms. So in that BT corn example, you have the monarch butterfly is actually eating it, and it's not going well. The monarch butterfly is declining in populations. You have this decrease in genetic diversity. One, you end up with a lot of the same crop or monocropping, because if a farmer's investing in GMOs, you're getting a lot of the genetically identical seeds, and so you're growing all the same thing. And if I grow all the same thing and some kind of disease comes in, I lose my whole crop. Whereas if you have that genetic diversity, if a disease comes in, then maybe one part of the crop is bad, but the rest are good, and that is economically good for me as a farmer. And then another problem is that GMOs possibly cross-pollinate with wild types. And, there's no way to really control pollen. So now that we've talked about our produce, we're going to talk about our meat. And so here we go. Most of our meat comes from feedlots. And so feedlots are also called concentrated animal feeding operations, or CAFOs. Basically, these are the factory farms. We have chickens in cages laying our eggs. We pack all the cows all into one place, and we pack all the pigs into one place, right? So there are huge warehouses or pens just to deliver food to animals and just produce them really, really fast, and a lot of it. And so it's, you are going through a lot of feed. So a big problem here is that you're actually watering the crops. And so that's a huge footprint or ecological footprint. Whereas like the animal themselves may be penned in and not having the physical footprint themselves, their food is. And with that comes a lot of disease and, right, a lot of antibiotic use because of that disease. And so, there's a lot of water pollution. There's a lot of waste going around, which again, right, introduces disease. Whereas you have a massive amount of food being produced, and in countries where we eat a lot of meat, like here in the US, it provides us with meat, right? That's great. I like steak. But they take livestock off land, like I said, and also reduces the impact that they would have on it. On the flip side, that land is being used to actually grow corn or grain for the cows. P.S. Cows don't actually eat that naturally. They eat grass. And so in looking at what we're feeding them, if I look at how much I'm feeding them, the amount of feed that you have to feed a cow to produce 1 kilogram of beef is like almost 20 times more than just to drink 1 kilogram of milk. Right? That's a lot of milk, but you know what I'm saying, right? Or almost 5 times as much as eating eggs. And so, right, the lower down on the food chain you eat, the less energy and the less input you're going to have to put into it. Not to mention, different animals will break down the feed that they're given differently depending on what they're given. Cows weren't meant to eat grain, and so that's why it takes so much to feed them to a point where we can actually get a product for them. So free-range grazing, look how happy they look. You know, these happy chickens, right? They're roaming outside for at least part of the day. It's more sustainable than these feedlots because they're walking around the pasture, they're manuring, urine, or fertilizing the land. There's less disease because they're not highly packed in there, which means I don't have to give them antibiotics as often. However, free range is very expensive. You need more land because you need the cows to graze something down, and then you need to be able to move them. So you can't have as many cows. So the amount that you're producing is a lot less. So whatever we choose to eat is we are also choosing how we're using resources. Land and water are needed to raise food for livestock. And then that livestock then needs land and water. And so producing eggs and chicken will require less space and water, and producing beef requires more. And so the lower on the food chain, again, I'm going to say it again, right? The lower on the food chain that you eat, the less impact you have, because if I'm eating an animal, that means that I also am eating what they have eaten, and what they have eaten needs to be grown.